All right, this video is to practice section 4.5 in PreCalculus, talking about the number e and using and finding equations and solving problems using the continuous base e. So I'm just going to do a few. I picked some here. I'm going to do 20, 24, 30, 32, and 34. Your homework is on this page. I gave you odds because you have the answers in the back of the book, but I wanted to do some even ones. So the first one I'm going to do is 20. And when we look at 20, and I'll just be writing it right on here, so you can do this all in your spiral notebook, is a town starts with 10,000 residents, and it grows at a continuous rate. So as you read this, I know if it starts with, that's my initial value, that's my A, and it grows at a continuous rate, I know that's base E, and if it's growing 4%, that means I'm going to have a positive K, and I'm going to change it to a decimal. Okay, so I mean, as I read it, I actually kind of do all that to it. So it says, write a formula of the population after T years. So we're going to use P's and T's. So for the A, my population started with an initial of 10,000 residents, and it's continuously growing 4%. Move your decimal place over 0.04, 2 to the left, to the T. So for the A part, basically, is you're taking the English words and you're doing a math sentence with it. So that's pretty cool. And remember, this is in years, and we might as well label that. This is in years, and this is the population. So I always like to know what everything stands for. And I'm using Christmas color. So B, what is the population of town after 5 years have passed? Well, all you need to do is plug in for 5. So I'm going to do P is 10,000. E to the 0.04 times 5. And when I get that, I put that in my calculator, I get 12,214 residents. And if I were to get a decimal, I would round up or down because we're talking about people, so you don't want to have part of a person. That would be gross. I'm going to go back to red. It says, find the annual growth rate. Now, we've talked about this already. If it asks you for the annual growth rate, and this isn't continuous, basically what you're doing is taking this formula and converting it to y equals a b to the t. And the b to the t, or the b, is in the same spot as if I wrote this exponential. The b and the e to the k are in the same place. So you're basically going to do b is going to equal whatever e to the k is, and then you're going to convert it. So because b is your annual. So I'm going to say b equals e to the 0.04. When I put that in my calculator, I get 1.04081. And anytime you deal with base B, you have to deal with a 1, whether you subtract it from 1 or take 1 away from it. So here I'm going to take 1 away from it, move my decimal place. So this basically means it's 4.081% annual growth rate. And remember, the reason why it's more is because if it's continuously growing 4%, like over the entire year, you're really growing that much over the whole year. So that's pretty cool when you have continuous. All right, the next thing I have to do is 24. So that's on this page. So I'm going to clear this. And I'm going to do 24, which is also on this page. So here's 24. It says, City A has a continuous growth rate of 15% per year. Okay. And then it says City B has an annual growth rate of 16% per year. Which city is growing the fastest, and justify your answer? So let's kind of set this up. So we're doing number 24. So I'm going to set them both up. I have City A and I have City B. So let's kind of do what the formulas have. And lots of times you don't have all the information, but then you're trying to figure out which one is growing the fastest. So City A is continuous, so I'm going to write down y equals a e to the kt, and then plug in everything they said. They said continuous growth rate 15%. So all I'm going to do, and it's growing, so it's positive, is write it here. I don't know anything else besides that. City B says there's an annual growth rate of 16% per year. So this is going to be y equals a b to the t. Now, if it's 16%, that's going to be 1 plus my rate, 1 plus 0.16. So this is a 1.16 to the t. Now what they want to know is which one is actually growing faster. And actually, this kind of, we can show the justification with math, but in my head, I already know this is growing faster because this is continuous. But this one I know is growing 16% per year, and it's growing just by looking at it. And we came up with it, and that's annual, okay? So this is 16% growth. Let's look at it for e to the k. So if I put e to the 0.15 in my calculator, I get 1.16183. When I get rid of the 1, because you've converted, this is really b, and move your decimal place over, this really comes out to be 16.183% growth. So this one, city A, is actually growing faster, which I kind of thought, if it's a continuous growth rate versus just an annual growth rate. Sorry, that was my alarm that just went off. So that's it for 24. So let's look at what we have. The next one we're going to do is 30. And 30 is on the next page. So let's go to 30 here. So here's 30. Do this. Whoops, sorry about that. So 30 says find the effective annual yield and continuous growth rate if Q equals 5500 e to the 0.19 t. All right, so that's the one we're going to do is 30. So when I go to do 30, I'm going to kind of go back a page because there's room to write. I just wanted to show this. So here's 30. They have Q, I'm just going to write down what they said, equals 5500 e to the 0.19 t. And this is the continuous growth rate. Is going to be 19%. Okay, you can tell because it's with base E, and I know that's the continuous growth rate. If they want to know your effective annual yield or the annual, if they say something like this, you're basically converting to base B. So what I'm going to do is take e to the 0.19, put that in my calculator. I get 1.20925. And if I get rid of the 1 and move my decimal place over, this really means a 20.925% effective annual yield. I forgot the L there, my effective annual yield. So even though it's continuously growing 19%, because it's always happening and you're getting interest on your interest, you're really earning this over a year. Is actually you're earning 20.925% on your money. All right, the next one I want to do is 32. So 32 I have is right here. It says, how long does it take an investment to double if it grows according to this formula? V equals 537 e to the 0.015 t, assuming t is in years. All right, so I want to know how long it takes for my investment to double. So I'm going to go back to this page where I have some place to write. So we're going to do 32 right here. So 32. Whoa, sorry, I keep hitting it. Come back, there we go. So 32, I want to know when this investment doubles. So here's my investment, and they gave me this formula for my investment. And it's growing. V equals 537 e to the 0.015 t. And they told me t was in years. And this is in dollars. So this is in years. I always label the crap out of it. And this is my investment in dollars. So I basically want to know when it doubles. Well, if this is what I start with, if I double it and put it here, so that's 1074 equals 537 e to the 0.015 t. If I want to know when it doubles, this is the formula I'm looking at. So what you're going to do is in your graphing calculator, graph the left, graph the right, and see where they cross to find out how long it takes for it to double. So I'm going to do a nice graph here because life is in quadrant 1. So here's my time in years. Here's my investment in dollars. So this is my sketch. So this is going to be 537, and I know it's growing. And I want to know when it doubles to $1,074. So you're going to graph that and see where it crosses. Wherever it crosses will tell you how long it takes to double. So just make sure that it shows on your screen. When I did that, I found that t equals 46.2 years it takes for it to double. This problem actually involves logs, but because we haven't got to that chapter yet, I want you to do it this way. So you can do this to anything that I give you. Okay. The next one I'm going to do is 34. So I'm just going to set it up here. It's on the next page here. So 34, let's go down here. Okay, so 34 says, if I can bring it down without making you dizzy, there it is. It says, find the effective annual rate if $5,000 is deposited at 2% annual interest compounded continuously. So it always is confusing sometimes when they say annual interest and then compounded continuously. If they say continuously, then you're going to use the PERT formula or y equals AE to the KT. They both work. So I'm going to go down to that on this page. So 34, you can use y equals AE to the KT, or I did show you the balance equals the principal E to the RT. It's the same formula. It's just more of a money talk. So either one will work in this case, and I'll use green for money. So if I actually plug in the money part, I'm going to use B. The balance is going to be 5,000. E to the 0.02 because it says continuously compounding. So they want to know what is your actual effective annual yield. So remember again, you're actually converting to base B. So you're just going to yield, I'll put an L in there. So you're actually just going to put this in your calculator because B is going to equal E to the 0.02. And when I do, I get 1.0202. And when I actually go through and put that in my calculator, it comes out to be, well, excuse me, I already did. Move your decimal place, get rid of the 1. It's 2.02% is your annual yield. Okay? So there's a few that I did that are even. You need to work on the odds of the assignment that I gave you, and I hope that this helped.